Let's say we have an object and the object has a mass m, and then there's a force F that pulls it in one direction, and then we have the of course the object will move with acceleration, and the acceleration is a. Okay, what happens if we change the force? Now the new force is 2F, means here that the force is increased, then therefore the object will accelerate faster. So we can say that when the object when the force is 2F, and then the acceleration will be 2a. So from here we can make a conclusion that force or acceleration is directly force is directly proportional to a. So when you have higher force, the acceleration will be higher. So we need this relationship, and we're going to use it after this. And in the second situation, we have one object m, and then it is pulled by this force, and then we have acceleration a. And then we don't change the force F, we don't change it, but we change the mass. So in this case, the object will still accelerate, but the acceleration is lower, and the acceleration will be half. So we can say that when the mass is higher, so the acceleration will be lower. Or you can write the relationship, acceleration is inversely proportional to m. Okay, so when we have this situation, okay, for this one you can also write A is directly proportional to F. Okay, you can write like this. So we say this is a first relationship, and this is the second relationship, and then when we combine the relationship, we have A is directly proportional. Okay, we should use the sign directly proportional. So A is directly proportional to F, but inversely proportional to mass. And we can rewrite this relationship. F is directly proportional to A, or I can write M E. Okay, this is the relationship for second Newton law. Second Newton law. Okay, you must remember this. So according to the definition, you can see here we have one definition here which is important for you to know. Okay, in SI unit, 1 Newton is the force that produces an acceleration of 1 meter per second squared when applied on a mass of 1 kilogram. Okay, so we can write F equals K ma, where K here is the constant, and then we want to know what is K. So K equal F over ma. Okay, so F is 1 Newton. Okay, we refer back to this situation, or this definition for 1 Newton. Okay, so we have 1 Newton, mass is 1 kilogram, and acceleration is 1 meter per second squared. So when you put into this equation, you get 1. Okay, because you can cancel out the unit, they are equivalent, and 1 divided by 1 times 1, you get 1. So K is 1. So this formula becomes F 1 ma. So F equals ma. So this is the formula for second Newton law, and we are going to apply this formula to solve many problems. Okay, now let us try to solve this example. A worker pulls a load of mass 80 kg along a horizontal surface by a force of 160 Newton. If the surface is smooth without any resistance that opposes the motion of the object, what is the acceleration of the load? So you can simply apply the formula and write down the unit, all the information you have here. Mass is 80 kg, and then force is 160 Newton. So the question is, what is A? Okay, so F equal MA, A equals F over M. Mass is 80 divided by 160 Newton. So the answer is 0.5 meter per second squared. Okay, I think I make a mistake here. This is okay. We do it again. F is 160 Newton divided by 80 kilogram. So you get, cancel out this, you get 2 meter per second squared. Okay, so here's the answer. Okay, then you can go on with the second example. Okay, read yourself.